For this example, we're going to determine what the infinite series for x times cosine x looks like. So what we're really going to do is write down the cosine x series, and then we're going to multiply it by x. So I know that cosine of x is equal to, and again, cosine is an even function, and it does alternate. So even means we're going to start with 0, 2, 4, 6, 8 terms. So the 0th term is going to be 1 x to the 0th over 0 factorial minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus your ellipses equals the sum from n equals 0 to infinity, negative 1 to the n because it's alternating. I don't know why I put the x there, but it's x to the 2n over 2n in parentheses factorial. So if I want x cosine x, I'm very simply going to multiply everything term by term by an x. So instead of 1, this is x. Instead of x squared times x is x to the 3rd, but the 2 factorial stays the same. This will now be plus x to the 5th over 4 factorial minus x to the 7th over 6 factorial equals the sum from n equals 0 to infinity. And if you take a look at what happened, my negative 1 to the n is staying the same. My 2n factorial is staying the same, but I multiplied everything by an x. So that's like multiplying x to the 2n times an x to the 1st. And when you multiply two things with the same base, you add the exponent. So this is x to the 2n plus 1. And you'll notice that they're the odd powers now, 1, 3, 5, 7. So the numerator x to the 2n plus 1 looks like the original numerator for the sine of x.